Hello and welcome to the Analog Devices Precision Training video, which focuses on precision digital to analog converters technology. Discussed will be the R-2R architectures. We will highlight the associated advantages and disadvantages that these architectures have and the value they bring to your design. The most common DAC architecture is the R-2R ladder. This uses resistors of only two different values, where the ratio of these is 2 to 1. An N-bit DAC requires 2 N resistors. This DAC architecture is not monotonic by design, and the absolute accuracy is not a key requirement, and the internal resistors can typically have a 20% tolerance. To yield a monotonic DAC, the resistors need to match 1 part in 2 to the N. This architecture offers fixed input impedance. However, the output impedance is code-dependent. The benefits associated with an R-2R DAC include low noise, small dynamic transients, and fast slew rates. However, these benefits come at the expenses of high power and low channel density. Also, R-2R DACs do not integrate an output buffer, which offers further customization of the DAC's performance. R-2R DACs can be configured in current steering mode or voltage switching mode. In a current steering DACs, the R-2R ladder divides the input current into binary weighted currents. These are steered to I-out1 or I-out2 by current steering switches. The switches on resistance is negligible when compared with the R-2R ladder resistors. The switch sizes are scaled to ensure that this does not have an impact on the DAC's linearity performance by maintaining the same voltage drop across each switch. The DAC termination resistor is tied to the I-out2 line. This facilitates the biasing of this node for use in true single supply applications. This type of DAC offers a constant reference input impedance and an output impedance that varies with code. The current steering R-2R architecture offers constant power consumption with variable noise and flexible current outputs at high speed. In an R-2R ladder, it is important to have very tight matching between each bit and the sum of the lower bits in order to maintain monotonic behavior. In a segmented design, these requirements are more relaxed. For this architecture, the most significant bits are decoded to select one of the segments. In the case of 3 bits of segmentation, 7/8 of the current will flow in the parallel ladder structure, and 1/8 in the R-2R structure. Segmentation allows linearity specifications to be more easily achieved. In this architecture, the input impedance is much lower, leading to an improved distortion specification. In the voltage switching mode DACs, the output is a voltage and not a current. The DAC input impedance varies with code, and the DAC output impedance is fixed. The voltage source connected to VREF should have a low dynamic impedance. High reference voltages will degrade linearity due to reduced drive available from the CMOS switches used in this architecture. A positive reference gives a positive output voltage, allowing for single supply operation. The voltage switching mode architecture offers variable power consumption, which leads to code-independent output noise. Analog Devices has a large portfolio of precision DACs available. in both string and R-2R architectures, applicable to fit any application design. So, please check out our website for more details. To learn more about Precision DACs, continue to watch our next video in our DAC Precision Training Series. Click on the link below or go to Analog Devices Precision Digital to Analog Converter landing page.